Hello everyone, Happy New Year. In this video we're going to be solving a nice exponential equation. Wait a minute, isn't this already mid-January? Yes, but how many of you are still struggling when you write the date? You tend to write 2024 instead of 2025. I know that I made a 2025 special, but I'm also going to tell you a little kind of rundown on how I came up with this problem because, you might be wondering, where does this problem come from, or how do you come up with these kinds of problems? First of all, you got to remember how special 2025 is. Do you remember that? It is 45 times 45. You remember there's a shortcut. When you square a 2-digit number or 3-digit number that ends in 5, you take the tens digit, if it's a 2-digit number, and you take that number 4, and what is 1 more than 4? It's a 5. 4 times 5 is 20, and you just attach a 25 and you're done. You can use this shortcut, right? Obviously, no matter what you do, you hopefully know that 2025 is 45 squared. Let me tell you where this problem comes from, or how you come up with these kinds of problems, because you could easily make up one, and then we will talk about the solution, okay? So first of all, I want you to think about two things. Which numbers are perfect squares here? 4 and 2025. Great. And what is 4? 4 is 2 squared, and 2005 is 45 squared, right? So once we establish that, we're going to go ahead and take a look at the bases here. 2 and 45. What is 2 times 45? 90. You got it. There you go. So start with two perfect squares, raise them to the power x, write them as perfect squares, and take the bases, multiply together, you'll get the third number, and you can pretty much place it anywhere. I mean, this problem could have been a little differently, like 4 to the power x plus 2025 to the power x equals 90 to the power x. And there's different variations, but do they all have real solutions? That's a good question. Let's go ahead and find out if this equation has any real solutions, because this channel is about real numbers in general, right? Most of the time. There are some complex problems here and there, but I have another channel that is dedicated to complex numbers, which is aplusbi. Go ahead and check it out. Check it out if you haven't done so already. Anyways, so to be able to solve this problem, first we're gonna rewrite it, right? And then we're gonna do the following. Since 2025 is the largest base, we're gonna divide everything by 2025 to the power x. Let's do it. And this is definitely going to give us 1 here, right? That's good. This is 1. And now, what about these? This is 4 over 2025 to the power x. And this is 90 over 2025 to the power x. And that is equal to 1. Great. But these are very large numbers. I mean, they're not large, but they're small. They're fractions. But the denominator is too large. Wait a minute. We can simplify them. How? Notice that 2025 is 45 times 45. So think about this fraction, right? Write it as 45 times 45. And guess what? 90 and 45. They have a common factor. 45 goes into 92 times. Nice. So this is 2 over 45. Can that be simplified? Not really. But guess what? It can be squared. How? What do you mean by that? If you square 2 over 45, you will get 4 over 2025, because 45 squared is 2025. Why is that important? Because that's what I have here. You see that? Cool. This is 2 over 45. Let's go ahead and rewrite it that way. 4 over 2025 to the power x plus, now I'm going to replace this fraction with 2 over 45, which is the simplified version, right? You see that? Okay. And then I'm going to go ahead and set it equal to 1, because that's equal to 1. Nice. And also knowing this helps, right? I can replace this number by 2 over 45 squared. And what it does is it squares and then x to the power x, but I could also switch the exponents because they are going to be multiplied anyways, right? Some people say anyways is not a word. Anyways, it is. Too bad. Now, we can go ahead and use an awesome method. You know what it's called? It starts with S. Okay, we're not going to play hangman, but let me tell you, it's substitution. So we're going to go ahead and set 2 over 45 to the power x equal to something. I don't know, maybe t, u. Let's use u. then this becomes a u squared, and guess what? We get a real solution. Beautiful. How do I know that? Because the constant term is negative and the leading coefficient is positive. When they're opposite signs, then we always have a real solution because of delta. B squared minus 4ac. If A and C, if AC is negative, B squared minus 4AC is always positive. Make sense? I hope it does. If not, always ask questions. Sometimes I gloss over things and I don't go into every detail, but if I skip something, please let me know. I try not to, but at the same time, I don't want to make this video way too long. You kind of need to know the basics, but you can always ask questions, okay? I encourage you to ask questions, and I'm pretty sure someone will answer, if not me. So how do you solve this equation? It's quadratic, so can we use the formula? Absolutely, why not? Because factoring would be hard. Completing the square, yes, but anyways, I'll use the formula. Negative b plus minus the square root of b squared 1 minus 4ac plus 4, 5. Yay, the golden ratio, sort of, right? It is the golden ratio, or is it not? Anyway, something like that. You get the idea. This is u, but there are two u. If it's your birthday, it's happy birthday to you. So there are two u values. These are the values of u. And then we're going to set these equal to what? What is u? 2 over 45 to the power x. Let's start with this because that seems more positive, isn't it? So we're going to set it equal to this. And can I write it like that? Because it looks more golden ratio-ish. And now we're going to do the hocus pocus. Okay, not the hocus pocus, a little math magic. We're going to ln both sides. We can natural log both sides. And when you do, this exponent is going to move. X times ln 2 over 45 is going to be ln this. And of course, by division, you can get the x. Super easy, right? Once you get to this point, I think the rest should be easy. Do I need parentheses? Probably not, because the fraction bar works like that. But okay, fine. I'm going to use parentheses. I know some people are really irritated by that. Kind of like not being very strict or rigorous about it. So that should be the answer, right? But what about the other solution? That value is negative, so I'm like, it's interesting. So let's go ahead and do it. Same thing, 4 over 25 to the power x. By the way, even though I said that if you square this number, did I say that? Oops, it was supposed to be 2 over 25. Never mind. I take it back. So 2 over... okay, fine. I don't know why I keep writing the wrong numbers. 2 over 45. Okay, here we go. I'm going to set this equal to the second u value, which is this one. Negative 1 minus root 5. You can write it either way, but it doesn't matter. This is always negative. Why is that important? Because if something to the power x is negative and x is real, then x doesn't exist because there's no solutions. Make sense? You can't get a negative number from a positive base. Can you get a negative number from a negative base? Yeah, but it's kind of different, you know? So we have a positive base. So this is impossible. There are no real solutions from here. But there are complex solutions. So the question is, how do you find them? Let me quickly tell you, even though this channel is not about complex numbers. Remember A plus BI. Don't forget that. Check it out. Let me know what you think. So I'm going to do this. I'm going to set this equal to the absolute value of this number times e to the power pi plus 2 pi n all multiplied by I. Don't worry about the details because I go into details on my other channel. Just go with the flow. ln both sides. You're going to get x ln 2 over 45 equals ln 1 plus root 5 over 2 plus pi plus 2 pi n multiplied by I. You can also factor out an pi if you want. Divide both sides by this, and you'll get the complex solution. May I leave the rest to you as an exercise? Super easy. And let's check what Wolfram Alpha provides. That kind of looks like our solution, doesn't it? And there is actually the complex solutions. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.